All right, hi everyone. We are looking at extending our unit on ratios and proportions. And this time we're going to be using polygons and more specifically sticking to a lot of triangles to do our ratios and proportions. So when we start bringing in our different geometric figures, we talk about similarity with our proportions. So specifically, the definition of similar polygons is that two polygons are similar if their corresponding angles are congruent. So angles have to be identical. And the lengths of the corresponding or matching sides are proportional. Oops. All right, so we can write equivalent ratios with the sides, but the angles have to be exactly the same. So let's see what's going on here with our two triangles. Now, just like the word congruent has a symbol, that was your squiggle with the equal on top. If we drop off the equal part of that and just have the squiggle or tilde, this is read as similar or is similar to, just like the squiggle with the equal is congruent to. So we're going to be looking at just the squiggle part of that symbol today for similar. So we have two triangles, two right triangles going on here. And we are going to use these to identify all the matching angles and all the corresponding sides. Okay, so first off, which angle in triangle DEF, which is the bigger one, corresponds to A? So this is where you have to pay attention to the angles. So angle A is 60 degrees, which matches up with angle D. And why do they match? Because they're both 60 degrees. Now let's do the same thing for the next one. What about angle B? Angle B is 30, which matches up to E, which is also 30. And then we check our last one, C with F. C is 90, and so is F. So angle F, because both are 90 degrees. So this is where we have the corresponding angles are congruent for similar polygons. So we have congruent angle pairs going on. That's the first thing you have to check. If your angles are not congruent, these figures are not going to be similar. Okay, they have to be congruent first off. So does each angle and its corresponding angle have the same measure? Yes, it does. So there's our first part of the definition. Now let's do matching sides. Now remember, we already said that I've got triangle DEF there. Which side in triangle DEF corresponds to segment AB? Well, we already said that A and D match, B and E, and then C and F. So I can use that to write out my matching segments. So triangle DEF, which side will correspond to AB? That would be segment DE. And then if I do segment CB, again, I can use those letters. CB is the third and second letter. FE has to match. Order is important here. And then our last one, A to C is first and third letter, so it's got to go with D and F. Now let's talk about the ratios of these sides. So what is the ratio of side AB to the length of its side? So again, clue here, AB to its side. Use those words to write the ratio, which is why we talked about the word to being used to write the ratios. So segment AB over, and again, we're not talking about the segments, actually, we're talking about the length, so you don't need the segment bar. but AB over DE. AB, up in our little triangle, let's go back up to the picture for a second. AB has a length of 5. DE has a length of 10. So we're looking at 5 over 10. There's our first ratio. We'll simplify it in a second. Which becomes 1/2. Now let's do the next one. BC to its matching side, which is EF. So BC has a length of 4, EF a length of 8. So 4 over 8. So BC over EF. Sorry, I just lost my train of thought for a second. 4 over 8 reduces to 1/2. So far, so good. And then our last one, AC and its match. AC3, DF6. So 3 over 6 for 1/2. So they all reduce down to the same thing, and that's what you want to happen. Again, that means the sides are all proportional. So that had to happen. So what are the ratios equal to in lowest terms? They're all equal to 1/2, which tells you you have proportional sides. If one of those fractions did not reduce down to 1/2, then these figures are not similar because all three have to go down to the same thing. Are all three ratios equal? Yes. And that's what you want to happen. The angles have to be the same. All the sides have to be proportional, or the figures are not similar. All right. So let's take a look at what all of this means when we put it together. So because all three ratios are the same, the length of the corresponding sides are in fact proportional. Now, that 1/2 that we found for those proportional sides is our common ratio for these similar figures, which is specifically called a scale factor. In this case, it's a common multiplier. Now, scale factors have to be found in a very specific way, and we're going to talk about that in just a second. But more specifically, they are used in similar figures. Again, if your figures are not similar, you will not have a scale factor. And specifically, how do we find scale factors? Well, to make that ratio, we need the information from the new figure, and we'll talk about how to get the new one in a second, over the old figure. Now, given those similarity statements, triangle ABC, and then your squiggled triangle DEF, how do we know from our similarity statement which one is the new shape, which one is the old shape? So, or the first triangle in your similarity statement is your old one. Then R is similar to the second triangle in this statement is your new one. So in this case, triangle ABC oops, sorry, not triangle ABC. So in this case, our triangle DEF is similar to triangle ABC. Now, in another unit later on, we will get more in depth in our scale factors, but for right now, this is what we want to use when we're dealing with similar figures. So let's use that idea of similar figures and answer our first example. All right, so suppose triangle CAN is similar to triangle JOY. Like we did with congruent statements, you can stack those up to find exactly what matches with what. Stack up those letters. I'm going to make that just a little smaller for a second. So CAN can match with JOY. And so again, I know now which letters match with what. So first off, it tells me if angle A, I'm going to move this down a little bit. If angle A is 96, okay, so in my picture, we've got 96, and then it says N is 46 and C is 38. So N 46 and C 38. We can use this and that similarity statement to find the matching angles, because again, the triangles have congruent angles. So if C is 38 degrees, so is J. If A is 96 degrees, so is O, because they're in the same positions. And then if Y, I'm sorry, not Y, N is 46, so is Y. And now I can use that to find all of my missing angles in my triangle. So J is 38, Y is 46, and then O is 96. And this is why sometimes you'll see that idea of not drawn to scale, because angles C and J visually are very acute on the paper. But again, not drawn to scale means it's just an example, and the numbers may not match if you actually measure it. Now we can answer what we've got here. Oops, get back. So J was 38, O was 96, and then 46 for angle Y. So that's using your similar figures, because remember the angles are identical. Now let's write some scale factors. All right, tell us if the figures are similar. Write a similarity statement if they are, and then give the scale factor from A to B, figure A to figure B. So remember, figure A will be the old one, figure B will be the new shape. So new information will go over the old information. So any number from figure B has to be on top of figure A. So let's see what we get. So here's the old, there's the new. So let's start with our first set of sides. So now if I'm looking at that side of 8, which is KL, KL matches with FE. So KL over FE means I have 8 over 16 for 1/2. All right, let's do the other matches and see what we get. All right, now let's do JL. So JL over GE, which is 17 over 34 for 1/2. So far, so good. And then our last one, JK. Whoops, that's a little small. I'll make it a little bit bigger. JK over GF, which is 15 over 30 for another 1/2. And again, that's what you want to happen. So that 1/2 is your scale factor. And now we can use our two pictures here and make our similarity statement. Now remember, the old one comes first. So triangle EFG is similar to triangle. And again, the second one has to match the order. E had 52, so it's got to go with L. F had the 90, so K has to be next, and then J. All right, so now we have our scale factor of 1/2 and our similarity statement. Let's check number 3. All right, same situation. We're looking at rectangles here. Figure A is the old, figure B is the new. So first off, let's check again, new over old. So we're looking at, now there's no side letters here, so that's okay. This time we're just jumping straight to the numbers. So 22 matches with 11. So 22 over 11, which is a 2. Now let's do the next one. 7 and 12. That is not going to reduce, so we're just left with 7 over 12. And if you notice, these are not the same. And again, when they're not the same, you cannot finish this problem. There is no similarity statement when they are not equal. So it's done. There's no scale factor. All right, let's do the last one. We're using, again, that similarity statement and the information they've given us just to solve out these for the missing pieces. Now, notice you've got 2 J's and 2 K's in the bigger one, so I only need to solve for one of them. Now, we have 2 equations we're going to have to write and solve for this. So what we need to figure out, where do you have matching information already? And that's going to come from top and bottom from each of these pictures. Now, it does not matter which one you use, top or bottom. I'm going to go with the top because those 2 match. I'm looking at top of the little one to the top of the big one. So I'm looking at 10 over 25 equals. Now, because I've got 2 letters, I need to use this twice. Once to find J and once to find K. So let's do J first. All right, so if 10 is coming from the little one and it's on top, then my 6 needs to be on top, which matches with the other J. Then when I go to the bottom one, my 8 is from the small one and my K is from the large one, so 8 over K. Because again, we're going little to big for both of these. Now we can cross multiply and solve these out. All right, so 10 times J, 10J. Sorry, I'm going to make that a little bit bigger. Equals 6 times 25 for 150. And just in case we need it, I'm going to write out each step. 6 times 25. All right, so 10J equals 150. Divide your 10. And J is 15. All right, let's do the next one. Again, we'll cross multiply. 10 times K for 10K. 25 times 8. Whoops, not 80, just 8. All right, so 10K, 25 times 8 is 200. Now I can divide out the 10. And my K is 20. All right, so guys, I hope you enjoyed learning a little bit about how you can use your similar figures and your proportions to solve for your missing pieces in your figures. Please don't hesitate to reach out to me if you have any questions at all. Bye, guys.